Okay, so tadi kita discuss about about probability. So the only thing you have to remember from probability is the sum of all probability is 1. Okay, the sum of all probability is 1. So kita akan gunakan konsep sum of normal probability tu untuk understand the concept of normal distribution. Inside your notes, I think you see that we have a lot of big words there. Among the big words are central limit theorem, correction for continuity, finite population correction factor, sampling distribution of sample means. I'm not going to cover it now. Okay, I'm not going to cover it now. We're going to cover it later at the end of the lecture. So you don't worry about this. So there's what sampling error, standard error of mean, standard normal distribution, and z-score. Of all these things, the only thing that is important for you to understand, what is standard normal distribution? Okay, what is standard normal distribution? And that is the only thing you have to remember. Okay, you don't have to worry about the rest. Okay, what is normal distribution? The understanding is like this. Anything that if you measure often enough, you will get a normal distribution. Okay. So what happened? He goes around measuring everything, termasuklah askar-askar dekat Afrika. Apa dia ukur? Dia ukur tinggi, dia ukur kulit kepala, dia ukur. And all these measurements, he noted that the more measurement he takes, the more the distribution becomes normal. So the concept is the more things you measure about the human factor, the more it becomes of a normal. It doesn't matter. It could be your height, it could be your weight, it could be your blood glucose level, it could be your BP. Anything biological, if you measure it often enough, you will develop a normal distribution. There are things that you cannot get a normal distribution. Contohnya, length of hospital stay. Why? Sebab you tak nak duduk hospital lama-lama kan? Semua nak balik kan? Kalau boleh nak balik secepat yang mungkin, betul tak? Okay, so the concept of normal distribution is when you measure many times, you end up with a bell distribution. Okay, it's symmetry about the mean. You have the mean in the middle, then symmetry, same side, left side and right side. Okay, and it is never, the line never touches the x-axis. Okay, and the total area under the curve is 1. Remember, the probability is 1. The total area under the curve is 1. If you look at the standard deviation, 68.2% lies within one standard deviation of the mean. 95.4% lies within 2 standard deviation, and 99.8 lies within 2 standard deviation. 3 standard deviation. This is the empirical rule that is mentioned earlier. Okay, and the data value is represented by x, which has the mean. The symbol is mu. Okay, I'm missing my mouse already. Hello, my mouse. I don't know. Okay, here there's my mouse. This is the mean, mu. Okay, and the standard deviation of sigma. This is the sigma. Okay. So in general, when you look at normal distribution, it looks something like this. Okay, you have the normal distribution. This is an example of the blood pressure, diastolic blood pressure. Okay, so you can see here on the diastolic blood pressure, looking at the mean rise around 82, 83. Okay, one standard deviation, it is between 673 until 93. Two standard deviation is between 60 until 103. So right now I'm in the third standard deviation between this and this. Okay, so that is a story about the distribution. So what is our interest in normal distribution? Okay, so when that one is, you saw, based on real data, blood pressure, and you have the mean at 83. When you talk about standard normal distribution, standard means the mean becomes 0. The standard deviation become 1. Okay, so you look here, you have the mean of 0, standard deviation of 1. Doctor, what do you mean by variance of is 1? How do you get variance? The square of standard deviation is variance. So, kalau the square of 1 is 1. Kuasa 2 pada 1 adalah 1. 1 kuasa 2, 1. So, kalau 1 tu standard deviation, kuasa 2 variance. Jadi, ianya adalah, variance-nya adalah 1 juga. Okay. Kenapa penting sangat benda ni? Pentingnya sangat sebab yang ini. Okay. Sebab ini adalah jadual taburan normal. Apa yang dilihat adalah keluasan. What you're looking at is the area under the curve. Okay, let's go back. Let's go back. You see this line? The Z line? Where's my mouse? Hello mouse, where are you going? Okay. Okay. Okay, so this is the line. Okay, when I show you this line here, on my computer got no line lah. Got only on the screen. So you see the Z here? Okay. Kalau Z dekat sini, 1, maka when you look at the graph, 1, keluasannya adalah 0.341. Okay, nampak ni? Okay, let's go back. Let's go back. Yalah, contohnya. Kita start yang senang dulu. Okay. Kalau ini, maknanya keluasan sini adalah 0.341. So, let's go. Dia kata dia nak ni. 1 point berapa ni? 1 point? 1.3 lah. Kata 1.3. Kalau 1.3, 1.3, keluasannya adalah 0.403. So, when we're talking about probabilities for standard normal curve, we are talking about the area under the curve, which is darkened. So we're talking about this. So when you're talking about probability, it is very important for you to take note. Area mana yang digelapkan. Area mana yang digelapkan. Saya minta maaf, saya punya mouse hilang lagi. Okay, ni dia. Okay, let's go next. So, the further you get from the zero line, the larger the number becomes. You started from 0 at the mean, remember dekat line tu, kosong, and you finish at 0.5 here, when the line is 0.399, almost 5, 0.4. Kenapa bukan 1? Sebab ianya hanya sebelah. It is only one side. So, bila one side, you get only half. You see? Wow, one side. Okay, only one side. So the whole of this one side is 0.5. The whole of this side another 0.5. But during exam, you get a different kind of table. They also call it normal curve, normal distribution table. But now, instead of starting with 0, you start with 0.5. And the number get smaller. Okay, how to differentiate? Okay, you look at this line. 0.0 is 0.5. Then the curve is the other way around. The darkened area is the other way around. Okay. Okay. For example, let's take this value. 1.96. 1.96, the value is 0.025. Okay. So you compare. This here, in the table I show you now, 1.96. The value is 0.475. 0.475 plus 0.025 dapat berapa? 0.5. So in fact, it is the difference of the area that you darken. So in the first one, in the standard normal curve, this is the area that is darkened. In the exam table, this is the area that is darkened. Okay. Doktor cerita apa ni, doktor? Okay. Table mana kami nak tengok ni? Okay. So, what we're telling you, we're just telling you that the whole area under the curve, 0. For this half, 0.5. The whole area, 1. But now, which area, the value you take, depends on your darkening is after the line or before the line. If you darken before the line, it becomes like this. If you darken it after the line, you get like this. Okay, the table that you get for the exam is this one. Okay, doktor tak percaya. I give you the table that we give for the exam. So where is to get the table for the exam? Okay, the table that you get for the exam is given to you at drtamil.me. When you are asked to do the exercise, you are told to refer to a formula. And the formula is this. Okay, let's go to PS1, Practical Statistics 1. Okay, you are asked to refer to the formula for your references. Okay, so this is the formula. Click on the formula. Okay, so this is the formula. For your exam, when you get the formula, it is a sheet of 10 pages. All the formulas are here. Okay, all the formulas are here. When we ask you to refer to jadual ataupun normal, to normal distribution table, we are referring to table A1. Okay, it is not the ayam A1 that you buy from the supermarket, but table A1. Okay, so you're going to refer to this table. What is the important value that you refer to this table? Only one value that you have to refer to this table, 1.96. I do not know whether you can see this or not. Let's underline 1.96, 0.025. So this is the value that you have to memorize. Okay? Tak payah. Sebab kita, for the purpose of our concept for exam, we want what is the probability of you being in error. So your level of significance is 95% CI. 95% CI, 95% confident that your conclusion is correct. So you got 5% chance of error. To get 5% chance of error, what is the value of the T? The value of the T is 1.96. Doktor, itu bukan 0.5, itu 0.025. I know. But you take two sides. So two sides, dua ekor. So 0.025 times 2 dapat 0.05. So 0.05. So your level of cut-off point is 1.96. So in fact, you don't need this table. You don't need this table. Last time when Adillah, way back in the year 2007. 2002. I told her to memorize this number. You memorize this number. 1.96 for p-value of 0.05. I asked you to memorize for chi-square. Degree of freedom of 1. The value is 3.84. Did you ask yourself, the 3.84 come from where? Remember, T got no square kan? T equals 1.96 kan? Chi got square kan? You square the T, 1.96 is square, become how much? 3.84. So in fact, that value all come from the same value, 1.96. Okay? So that is the whole point of this lecture, to explain to you. During exam, this is the table that you get. And this table you get, the marking is after the line. The lecture that we gave you, the marking is before the line. Z value ni basically when you're trying to explain something. Okay, I give you exam question of this. That one explain the Z value. Okay. So let's go to the next part of the lecture. So if you are calculating the value of Z, you're calculating the value of the area, and you have to look at the value of Z. Okay? If the value is between 0 and any other number, you look up the area in the table. If the value is 2 positive, then you look between the two negatives. Okay. So 2 positive and 2 negative. So basically, you're looking at the total area. So don't worry about this. These are all the explanation. But better to look at the two rules. If there is only one Z score given, use 0.5 for the second area. Otherwise, you look out for both Z score in the table. If the two numbers have the same sign, then positive Z and positive Z, you subtract. If they are of different sign, then you add. So it doesn't matter. Okay, so that one is all not important. Why not important? Because we are not going to ask you to calculate the z-score from the probability. Okay, this is a sample of exam question. The concept is you have a value of mean of 90 milligram per deciliter and standard deviation of 19 milligram per deciliter. This is where I have to take off the mic and just shout my voice across the room. So you can see this is a sample question of the old time. In fact, this one used to be the standard benchmark question that we give to the batch before Adila. For many years, we give the same question every time, and this was the question. So the thing that I showed you on the diagram was like this. Okay, the things that I showed you on the diagram is like this. Okay, so here are all the answers there. A, the minimum normal glucose level is 60 milligram per deciliter. Okay, at the confidence interval of 95.4, you can see here CI of 95.4 refers to plus minus 2 standard deviation. So the value between them is 90 plus minus 2 times 15. Okay, 2 times 15, so 90 plus minus 30. So it is between 30 to, so between 60 to 120. So it's true. Second remark. So you have remark 2 standard deviation. So you can see for 2 standard deviation. Okay, I need to shift my mouse there. Hello mouse. Okay, mouse. 2 standard deviation 135. So you can see here already. This one is 135 is at the third standard deviation. So that's why the statement is false. 2 standard deviation, the value is only 120. C, 45. 45 is here. So it is correct at 99.7. So it is true. So distribution of 99.7, it is true. Glucose level at 1 standard deviation, 120 milligram deciliter. So 120. So here is supposed to be 90 plus 15. So 90 plus 15 is 105. So it is between 75 to 105. So it is false. This one salah. So 120 is salah. And last one is between 75 to 105. So 75 to 105 is correct. Okay. And that is the explanation about normal distribution. The rest are just what they call continuity correction. I'm not going to cover this now. Why I'm not going to cover this now? Because it's going to confuse you. Let's focus only on normal distribution.